Hi everyone, welcome to Terraform-Friendly API Design. My name is Patty Carver. I'm the engineering lead for the Terraform plugin SDK team at HashiCorp, and I use he, him pronouns. You can heckle me on Twitter about all of these really bad hot takes. I'm at Patty Carver, and I really look forward to hearing from all of you get mad at me about this. This is going to be awesome. I've already lied to you. The talk's just started, and I already need to apologize for lying viciously to you. This is not, in fact, a Terraform-friendly API design talk. That's not what we're here to talk about today. This is a Terraform provider developer-friendly API design talk. I just couldn't fit that in the submission form for the CFP for this conference. Really, what I mean by that, though, is I have been working on Terraform providers for 4.5 years now. I've never seen an API that Terraform couldn't handle. That's one of the great things about Terraform, is it's not expecting all of the APIs to conform to its idea of how the world should work. It uses providers for that. The job of a provider fundamentally is to be a translation layer between Terraform and APIs, between the theoretical model that Terraform has developed for how APIs work and the harsh reality of how APIs actually work in the real world. And so I'm really nervous about giving talks like these and writing documentation like this, even though people have been asking for it for a while, because I don't want to give people the impression that you need to build your API a specific way or you can't have a Terraform provider for it. That's not the case at all. Even if you don't follow any of the suggestions in this talk, it doesn't matter. You're still going to be able to build a Terraform provider. It's just going to be harder for your Terraform provider developer because their job is mapping your API to Terraform's model of the world. And the more you diverge from Terraform's model of the world, the more work they've got to do. So with those disclaimers in hand, let's take a look at how can we make Terraform provider development as easy as possible. Because that's part of what I view my job being, is to help people make Terraform providers, make more Terraform providers. And the easiest way to do that is to make sure that it's simple and straightforward to make a Terraform provider. This is a warning. There are spicy takes ahead. I'm going to get a lot of hate tweets and a lot of hate emails about this. That's okay. That's the job. But you don't need to agree with all of this, and I've tried to organize this talk so that the takes get progressively spicier as we go along. We're going to start with some stuff that I hopefully think that a lot of people will be like, yeah, that's just API design common sense. And we're going to end with some stuff that everyone's like, you want me to do what now? So that's kind of what's going on here. Again, know that you don't need to adopt all or even any of these to be able to have a Terraform provider. They're just going to make life easier for your provider developers. So let's get going. We're going to start with number 1. Be declarative. Have the concept of resources. And everyone's like, I mean, well, yeah, but we've run into a number of APIs that are RPC based. That's like start this thing off, and it takes, it takes a certain number of arguments or parameters to it. And then when you read it, it gets an entirely different set of arguments or parameters. And that's really hard to map into Terraform because Terraform's got this concept of resources, and it thinks that you can describe this one thing that the API is managing, and the API will tell you about it. And so it gets really tricky if you don't have the concept of resources in your API. The next is to return errors as early as you can and as many errors as you can. It's really unfortunate when you're a Terraform practitioner to be typing Terraform apply and have that fail, and then fix whatever error it's telling you about, and then type Terraform apply again and have it fail with a different error that you need to fix. Terraform has the ability to surface as many errors as you can throw at it back to the practitioner and surface them in a helpful, context-oriented way. And so if you can give back all of the errors in your API response, if you can do all of the validation up front, that's great. You should do that and tell Terraform about all of those errors, not just the first one you hit. Don't have any side effects during HTTP GET requests or your read requests. Who knows how many times users will run Terraform refresh? Terraform Cloud could run it several times in a row. You never know. As a general rule of thumb, if you're creating objects or entering things into a database or mutating things, every time you run Git, you're going to have a bad time of it because Terraform expects that to be a free operation. It doesn't expect you to mutate anything in response to it. Number 4, standardize on patterns. This isn't really Terraform specific, but it is possible to reuse a lot of behavior in Terraform providers. And if you can name fields the same way, if they behave the same way, or if you can follow standard patterns, then you can create these abstractions in your Terraform provider and take advantage of them. And that really speeds up development and makes it easy to keep things nice and consistent. Number 5, return as much information as possible. Terraform's job fundamentally is to make your API's state match the Terraform config that the practitioner specified. So it needs to know when there's a difference between those. But if it can't get information out of your API, if you won't return the current state of your API to Terraform, it's going to have trouble managing that. So sometimes, usually we see this as people being hesitant to return password fields, for example, to Terraform. If you can, return as much as you can. Give it as much information as you've got. If you can't, be predictable, and that's number 6. Terraform's job fundamentally is, would this request yield this response? If not, I'm going to make that request and get a new response for it. If it would, I'm not going to make the request. I don't need to do anything here. And so, in the case of the password example we just discussed, you're going to want to at least return like a hash that Terraform can calculate based on the information it has, for example, in your API to be able to check whether the value that it got from the API state matches up with what's in the config. It doesn't need to be a direct comparison, but when possible, at least return like a checksum or a hash or whatever you can do. Some people are like, great, I'll use a last modified date. That doesn't really work because to compare, Terraform needs to be able to check what's in a config against what's in the state. And so if you use a last modified time, Terraform's just going to be like, yep, I just read it and that was the last modified time and that doesn't diff with anything in the config, so that must be right. So you need to give it something that Terraform can compute from the config values the user has entered. And usually Terraform already has the password in the config. The user has entered it. So if you can then at that point calculate a hash from that password in the config to compare with the value that came back from the state, Terraform can do its job again. Number 7, have isomorphic fields. Terraform really doesn't like it when your string turns into an object. Doesn't like it when your string turns into a number. Doesn't really like it when types change at all, to be perfectly honest. Terraform largely expects types to be the same from the beginning of a resource's lifecycle to the end of it, and from the moment it's created to the moment it's deleted. Terraform expects it to have the same exact type. So if your API is relying on like a data object sometimes changing or having different values or having different types in it, for example, you should try and find a way to move away from that polymorphic behavior and kind of describe it in a more isomorphic manner. And that might mean rethinking your schema or your design for that API, but it does make Terraform provider development for your API just so much easier. As a side note, it also makes Go provider or Go client library development for your API so much easier, but that's a different talk. Number 8, have requests be transactionals. We've seen a few APIs that have you make requests to modify resources and they're just considered staged, and then you call a commit or apply endpoint to roll those changes out to production to make them actually go live. Terraform really doesn't like this. Terraform expects that when it changes a resource, that the resource is actually changed. Terraform has no model of do all of these things and then batch apply all of it. And so if you can avoid that, that's great. Otherwise, your Terraform provider developer is probably going to call commit or sync or apply or whatever it is after each and every request, which is probably not what you were hoping they would be doing. Avoid user interaction. This one's a little spicy because it's 2FA, but nobody wants to click a link or check their texts in the middle of a Terraform apply. Terraform is going to make it hard for you to do that because Terraform expects to be a machine interacting with an API. And so introducing any human element or human approval into the flow is going to have a bad user experience, and it's going to be tough for your provider developers to craft that bad user experience. If you can avoid it, please do. Number 10, offer, compare, and swap. We're getting to the real spicy takes now. Terraform, as part of its graph walk, first refreshes the state in that it gets from the API. It says, hey, API, tell me what you got. It then compares that against the config, generates a plan, gives that to the Terraform provider, and the Terraform provider acts on that plan. Now you'll notice there's a problem here. In between the refresh and the Terraform provider acting on the plan is an unspecified amount of time. What happens if somebody goes in and modifies your API in that time? Well, for most people, you just end up in an unspecified bad state, and that's not ideal. However, if you can offer a compare and swap like a e-tag or other checksum of the current state in your read requests, and then can accept those in your update requests, then Terraform can pass them along and say you can detect race conditions then in the update that Terraform is doing. And so that's one way that you can kind of have a more robust plan and apply kind of lifecycle for Terraform, is if you offer compare and swap. Number 11, we're real spicy now. Avoid defaults. Defaults are rough in Terraform because to do a default properly in Terraform, you've got to make it optional and computed. When you make it optional and computed, it says, hey, if the user gives me a value, great, let's use the value the user gave me. Otherwise, I will specify a value from the API. However, when you do that and the user doesn't specify a value and you're going with the defaults, right? Terraform loses its ability to detect drift because you told it whatever you sent back from the API is just fine. So it doesn't know whether it's the default or whether someone went into the console and went and clicked around a bit. It has no idea and it doesn't care. It's never going to prompt you for a diff. If you can avoid defaults, then you can have the Terraform practitioners config specify all the fields, which enables Terraform to track all of the changes you're making to it. We're in real spicy take land now. I don't know if you can tell. And this next one, this is the spiciest. Ignore the robustness principle. The robustness principle is an API design principle that says you should be liberal in what you accept as input, and you should be conservative in what you kind of output from your program. And so the idea being here, you can accept input in a variety of formats, but you're only going to return input or return data as one format. You should not do this as a Terraform or as an API that you want to build a Terraform provider for. Normally we see this as normalizing. It's like, oh, you sent me a relative path. We're going to give you back the full URL for it. Or you sent me a string. We're going to give it back to you all lowercase. This means that then Terraform has to understand how to normalize it because Terraform does byte for byte comparisons. If your value changes byte for byte, then your Terraform provider developer has to then understand the semantics of whether the value actually changed or not and map them back and forth. And so that's a lot of work that they've got to do, and it's subtle work. So if you can avoid doing that, if you can just always give back data the exact same way that you got it in, that's going to make your Terraform provider developer's life much easier. So those are my 12 different tips. I hope that was helpful. Hopefully that answers all your questions, and happy terraforming.